Hello and welcome. In this video, we're going to talk about the relationship between a function and the derivative of its inverse function. And we're going to learn how to identify that using a table and using the relationship that exists between a function and the derivative of its inverse. So let's go ahead and jump right in. So we're actually going to derive this relationship between a function and its inverse, or the derivative relationship between a function and its inverse. So we know that two functions are inverses if this purple statement is true, if the composition of those two functions is equal to x, which means we could find a derivative relationship by simply taking the derivative with respect to x of both sides, and that's what's written here. So if I take the derivative, on the left-hand side, I'm going to be applying the chain rule. So f prime of g of x times the derivative of the inside, the derivative of the outside function evaluated at the inside, times the derivative of the inside function, that's how the chain rule works, equals, well, the derivative of x is just 1. So if we wanted to solve for the derivative of the inverse, so now we're going to solve for g prime of x, because that is the derivative of the inverse, we would get this relationship, that g prime of x, which is the same thing as the inverse, so I'm actually going to write it this way also, is equal to 1 over f prime of g of x. So we now have a relationship that exists between identifying or finding the derivative of the inverse without actually necessarily needing to know the exact function. If we know a particular value and we know what the original function is so we can find its derivative, we can relate these two things together. So this is a formula, so to speak, that you need to know. And I guess if you didn't know it, you could do what we just did right here and you could derive it. But knowing it is going to make your life a little bit easier. So in general, if f and g are inverses, then the derivative of the inverse is equal to 1 over f prime of g of x. And what we're going to do for the rest of this video is really focus on how do we use that formula. But that formula is probably a good idea to write it on a post-it note, keep it with you, put it on your binder so that you see it repeatedly so that it stays with you. Or, I guess, worst case scenario, you could derive it the same way that we did here. So let's look at some practice problems. Okay, given the table of values for f and the fact that g is the inverse of f, determine the following if possible, and if it's not possible, state why. So this problem is talking about f and g are inverses, so I'm just going to make a little note to myself here. F inverse is g. We're just calling it g so the notation is a little bit less confusing. We know, based on what we just came up with, that the derivative of g of x is 1 over f prime of g of x. So let's go ahead and look at number 1. Number 1 is asking us for g prime of 1. So what does that mean? That means 1 over f prime of g of 1. So in order to evaluate this, the first thing that I need is I need to know what g of 1 is. Well, when I look at this table, I don't see any ordered pairs at all for g of x. So that's already kind of confusing. But remember what we learned in the last video is that if I have values for f of x, all I have to do is switch the x and y coordinates to find values for g of x. So let's go ahead. If I look in this table, this ordered pair in f of x, when x is -1, f of x is +1. That means in g, I could just switch the x and the y coordinates. So I know that when x is 1, g of x is -1. So let's go ahead and do that for all 4 of these points here. When x is 0, f is 2. Which means when g is 2, when x is 2, g is 0. And then lastly, in this column here, When x is 1, f of x is 5. So when x is 5, g of x is 1. And I'm actually going to just add a table here for g of x. And I'm going to fill in any information that I know. I know what happens when g is 1, when g is 2, and when g is 5. So I can't put anything in this first box over here where x is -1 because I don't know what happens when x is -1. But if x is 0, I also don't know what happens. If x is 1, then I know I have -1. If x is 2, so I'm going to add to the table over here. If x is 2, I know that g of x is 0. And if x is 5, I know that g of x is 1. So let's clean that up a little bit. There we go. So what do I need in order to answer question 1? I need to know what g of 1 is. Well, g of 1, I can find from my table right here. G of 1 is -1. So let's just plug in that piece of information. That means this is going to be equal to 1 over f prime of, what did we say g of 1 was? -1. Well, now I just need to look at the table to figure out what f prime of 1 is. So if I look in the table, f prime of -1. F prime of -1 is right here. So that is 1.5 or 3 over 2. That means this is 1 over 3 over 2, which is the same thing as 2/3. So g prime of 1 is equal to 2/3. Let's go ahead and look at number 2. Number 2 says g prime of 2. Well, this would equal 1 over f prime of g of 2. So what's the first thing I need? The first thing that I need is g of 2. So I'm going to look at my table and see if I can tell what that value is for g of 2. Well, here x is 2, g of 2 is 0. So I know that g of 2, I can plug in 0 here, which means now I need to find f prime of 0, which I can go to the table to find. F prime of 0 is 2. So g prime of 2 is equal to 1/2. So this is really about getting comfortable with the formula. This conceptual sort of table type of problem is really standard, and making sure that you know how to use the information that you have to finish the question. Okay, so if I look at number 3 here, g prime of 0 would be equal to 1 over f prime of g of 0. So I need to know what g of 0 is. Well, g of 0 we don't have in this table. So for number 3, we're going to say this cannot be determined. It's not that this doesn't exist, it's that we don't have enough information. We only have a certain number of values in this table, so we can just say we can't determine what the value of g prime of 0 is without knowing what g of 0 is. Okay, number 4. G prime of 5 is going to equal 1 over f prime of g of 5. So I'm going to look at the table. Can I figure out what g of 5 is from the table? G of 5 is 1. So this is going to equal 1 over f prime of 1. Can I figure out what f prime of 1 is from the table? That's going to be 1/2. So this is 1 over 1/2, which is the same thing as 2. So the derivative of the inverse at a particular value is 1 over the original function's derivative evaluated at g of that particular value. So let's go ahead and look at some more examples. Okay, so let f of x equal 1/2 x to the third plus 4x minus 4, and h is the inverse of f. And then we are given a specific piece of information here. Note that f of 2 is equal to -14. Find h prime of -14. So since we know that these two functions are inverses of each other, we can set up h prime of -14 using the same formula that we have already been using. So this is going to equal 1 over f prime of h of -14. So now you might be wondering, I can see the function f, right? We have f right here. but we don't have any information about h. And in order to evaluate this, the next piece of information that we need to know is what is h of negative 14. We need to know this value, otherwise we can't do anything. So what they gave us in black up here was that on f, there was the point -2, -14. What point does that mean exists on the inverse? It means the inverse, which in this case is h, would have the point -14, -2. So we do actually know what number goes here. It's going to be -2. So I can rewrite this. H prime of -14 equals 1 over f prime of -2. -2 is what h of -14 is. Now you might be thinking, okay, but what's f prime of -2? Well, we have f of x, which means we can just find the derivative by simply applying the power rule here, 3 over 2x squared plus 4. And we care specifically about what happens when x is -2, so we can just plug -2 in here. And this is going to give me -2 squared is 4. 4 times 3 is 12, so 12 over 2 plus 4, or 6 plus 4, 10. So this is going to be 1 over 10. So h prime of negative is equal to 1 over 10. So I want you to kind of think about what we just did for a minute. We just found the derivative of the inverse without actually finding the inverse function itself. We could have, if we really wanted to, rewritten this as y equals 1/2 x cubed plus 4x minus 4, and then switched x and y, and then solved for y. Now that's a really complicated way to come up with the inverse function if all we care about is one particular value of its derivative. So this formula really comes in handy in this particular circumstance where we're looking at the derivative of the inverse at a particular value. Okay. I encourage you to look at number 6, read through it on your own, and then see if you can work through it without me helping you. Then you can unpause the video and see how you did. Okay, let g and h be inverse functions. Given the table below, find h prime of 3. So h prime of 3 would equal 1 over g prime of h of 3. Well, we know what h of 3 is. When x is 3, h is 4. So this is equal to 1 over g prime of 4. And we can use the table to figure out what g prime of 4 is. G prime of 4 is 1/2. So this is 1 divided by 1/2, which is going to be 2. So h prime of 3 is equal to 2. Let's look at just a couple more examples and then we'll wrap up. Okay, given the table of values for f and the fact that g is the inverse of x, determine the following. If possible, if not possible, state why. So again, I'm going to encourage you to pause the video and try and work through this on your own, and then unpause the video and see how you did. So hopefully you have had time to try this on your own. The very first thing I'm going to do, since I have multiple parts, is I'm going to fill in anything that I know about g of x. So I'm going to come off to the side because it's just easier for me to see. I know that in f, I have the point 1, 1. I have the point 2, 5. I have the point 5, 8. And I have the point 8, 9. And I'm getting all of that from right here in the table. What that means is in g, I have what I get when I flip all of those points, right? When I switch x and y, because that's what inverses do, I have all of these points. So I'm going to fill in what I know in the table. This first value, when x is 1, g of x is 1. I don't know what's happening when x is 2. I don't have an ordered pair that gives me that information. I do know what happens when x is 5, though. When x is 5, g of x is 2. When x is 8, g of x is 5. And I can add a column here. When x is 9, g of x is 8. Since this is a multi-part problem, it seems worthwhile to just do all of that up front. If it was a one-part question, maybe I wouldn't spend the time doing that because maybe I only need one of those values. But I think it's helpful to just sort of put everything out there that we know at the beginning. So for part A, to find g prime of 1, I need 1 over f prime of g of 1. If I look at my table, g of 1 is 1. So I need 1 over f prime of 1, which I can also find in the table. F prime of 1 is 3. So g prime of 1 is 1 over 3, 1/3. I'm going to come down here to do b because I don't think I'm going to be able to fit it in that teeny tiny space. G prime of 5 is going to equal 1 over f prime of g of 5, which is going to be 1 over f prime of, let's see if we can find g of 5. G of 5 is 2, so I'm going to have 1 over f prime of 2. And if I look, f prime of 2 is 6. I'm going to get 1/6. So g prime of 5 is 1 over 6. And then last but not least, part C, g prime of 8 is going to be 1 over f prime of g of 8. 1 over f prime of, so g of 8 is 5, so 1 over f prime of 5. And this is going to equal 1 over 10. So if you're ever getting to a place where you don't have a specific value that you need, double check that everything that you have written down is right, and then it's possible that you don't have enough information to find that value. That doesn't mean that value doesn't exist, it just means you don't know enough to determine what that value is. All right, we're going to look at one last example. Okay, number 8, if f of x is x cubed plus x and g of x is the inverse, find g prime of 2 if g of 2 is 1, and g prime of 10 if g of 10 is 2. So go ahead and pause the video and see if you can do this on your own, and then unpause the video and see how you did. All right, I'm going to start just by writing out what I know. G prime of 2, since these are inverses, is 1 over f prime of g of 2. We know that g of 2 is 1, so this is 1 over f prime of 1. What we need now is to know what the derivative is. Once we know what the derivative is, we can find f prime of 1. Since I'm probably going to need this for both problems, I'm going to just come down here and find the derivative. F prime of x is going to be 3x squared plus 1. What we need for this problem is f prime of 1. If I plug in 1, I get 3 plus 1 is 4. So this is going to be 1 over 4. And last but not least, to find g prime of 10, we will take 1 over f prime of g of 10. G of 10, they are telling us this is 2. So this is 1 over f prime of 2. And then we already figured out what f prime is. If we plug 2 in here, we're going to get 3 times 2 squared is 4, so 12 plus 1 is 13. So this is going to be 1 over 13. So to recap what we covered in this video, the most important thing that we covered is that to find the derivative of an inverse, we need to take 1 over f prime of g of that value. This is the key idea in this lesson, using this formula. Now, this formula only works if f and g are inverses of each other. If not, we're going to have to take a completely different approach, or we're probably not going to be asked a question just like this. So if we have two functions that are inverses, this relationship exists and allows us to work through those values. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.